All right, now let's go to the week 6. Now, remember, week 5, I told you from week 5 onwards, now we are trying to focus on the modeling part, right? So we have done plenty of SQL stuff, right? Writing queries, right? Aggregate functions, etc., etc. So now the time has arrived as to focus and go a little deeper into the modeling aspect of the database. How are you going to model it, right? So using entity relationship diagram. So in this lecture, we try to learn how to read and interpret narratives, right? So we'll provide you the narrative. So narrative is very important, right? So so usually how we develop the narrative in practice, when we interview with the users, we'll convert the interview scripts into the narrative, right? Then the narrative will take it as a kind of a resource to develop this ER model, right? So in this semester, I'm not going to ask you to okay, develop business narrative, right? So narrative will be given by us, right? But there are some other units like the next year, or sorry, next semester. You will do INF 20015 requirement analysis and modeling unit with me. So I am convening that trend. So you will learn how to develop narratives for a given problem. Okay. So in this semester, we are not going to touch that. So I will give you all the narrative. What you need to do is read that and create the relationship diagram. So we will practice lots of questions, and also we will get some test questions as well. In a test 2, you will get to design an entity relationship diagram based on the narrative. Okay. Um, and one of the important thing that you need to remember is the notations or the style of notations we use in this unit is very peculiar to our unit. So please stick with the styles that we are going to use. Now, why I'm asking you to use the same style or the conventions that we adapted? Because when you go to the industry also, each company or each maybe different client that you are working with, probably they have their own notation and notation styles, right? So you can't and tell, okay, we use this another different type of notation. No, you can't say like that. You need to adapt it to it, right? So therefore, please let's practice it. How we're going to use a particular style, right? So we'll stick with this style in this semester. So if you go through the internet or Google, you will see there are lots of other styles like chain notations. So these are the different styles of styles we use to create ER diagrams. And then you may have UML type, we call Unified Modeling Language notations. So they have their own style of notations. Probably we will use these kind of styles of ERD diagrams in when you come to more advanced unit in next semester. INF 20015 unit. And you can see there are so many these kind of styles as well, but we are not going to use. And you can see boxes and kind of other kind of notations. Boxes, different types of boxes, so don't use it. So you know our style, we are using a box with a lollipop kind of thing to show the attributes, and then double line box for the weak entities, right? So these are the things you need to learn. Okay? Right. Now, first thing first. Now, I am giving these steps. How you going to design? When to start? Which place to start? How to start actually designing interrelationship diagram? Now, if these actually steps are not described in any textbook, I thought that I'll actually list these steps for my students, because these are the steps I learned from my teachers. And even when I work in the industry, I learned these steps, right? So I thought I will give it to you guys, because I haven't found any kind of these kind of very meaningful steps listed in any of the database kind of texts. Right. So these are the steps you can follow to design the interrelationship diagram. Now, step number one is when you read the narrative, what I will do actually, I try to actually find out strong entities, right? Now, remember the strong entities and the weak entities that we discussed in the last week, and then I try to identify the attribute. Now, sometimes it's really difficult, right? The entities, attributes, how are you going to distinguish these two? Okay? Um, so once you identify strong entities and attributes attached to these strong entities, then the rest is actually really easy. So then what we can do is, then we can assign these attributes to strong entities, where we can go through these attributes and see, okay, this attribute goes to this entity, that attribute goes to this entity, etc., etc. So likewise, we can attach, right? So that is step two. And the third step is, once you attach all these attributes to strong entities, you may find out, okay, do we have any relationship between these strong entities? For example, do we have relationship between the students and the subjects? Do we have any relationship between the movies and the actors, right? So you need to actually ask questions by yourself, right? So when you identify the relationship, then you need to link that relationship. You need to put a kind of a line between these two entities to indicate the relationship, right? And then the next step is, you need to determine the cardinality of the relationship and cardinality of the constraint. How many instances in one entity related with other instances in the other entity? That is what we mean by the cardinality relationship. And the cardinality constraint determine how many times these instances repeat in the other entity. Is it many times, or no, sorry, it is mandatory, or is it non-mandatory, or is it optional participation, right? So it is optional, then you can put a kind of a circle. If it is a mandatory participation, you can put a kind of another hash sign. So that is what we mean by the cardinality constraint means. Okay. So how are we going to determine cardinality relationship and cardinality constraint? Based on the business rules, right? Because when you read the narrative, you will actually obviously find out the business rule, how these particular business process their information, how they use this information, right? How these information, or how that they govern their data, right? The interaction between different objects, how they govern, what are the specific rules attached to these relationships. So then you can find out easily the cardinality relationships and cardinality constraint, right? So that is the step 4. The step 5 is, the thing is this: once you actually attach these attributes, identify and attach these attributes to strong entities, you may actually find there may be some few attributes remains in your narrative, which you can now attach into the relationships, right? Because sometimes the relationship itself will actually give you another idea. Okay, we can have another weak entity in between these relationships, right? So therefore, temporarily we are attaching the remaining attributes to the relationships, right? Or relationships between the strong entities, in other words. Okay. And then what we have to do is, we have to go through the many-to-many relationship. If there is any many-to-many relationships between the two strong entities, what you need to do is, you need to expand it. What we mean by the expand it means, we need to take that relationship out, and we need to create a weak entity in the middle, right? And then we need to reverse the cardinality and the participation constraint towards the weak entity, right? Okay, so that is what we mean by the step 6. And I think we have done that last week. Remember, we once how to create a weak entity, how we are going to shift this many-to-many relationship towards the other end, right? So that is what we mean by step 6. And in step 7, we can now attach the remaining, whatever the remaining attributes to these appropriate expanded entities. Okay? And then what we can do is, we can actually determine the identifiers of each entity. Now, I determining the strong entity identifier is very easy because we can do it in very straight away in the first go. But once you expanded these many-to-many relationship, now we can have kind of an idea what should be the identifier for each of these expanded version or the weak entities that we have created. Okay, so that is the step 8. And then as a good practice, what we can do is we can put some test data and see whether our model is working, right? That is actually a very good habit of I mean, developing this kind of model, right? So creating some test data. Um, and the other important thing is we can read the entity relationship in both directions. Now remember, the relationship has to be established in both directions. So we can test it whether it is working. We can navigate through the diagram and see whether we have missed any kind of participation or constraints or anything like that. Or maybe we can even do some sample queries and see whether we can produce the required reports based on the model that we have created. Okay. So basically, these are the 9 steps, right? These are the 9 steps you can follow. It's not that difficult actually. Now it looks like initially, oh my gosh, it's too much of steps. But when you practice it, it's super easy. It's super easy, right? Not that difficult, right? What we need is the practice, right? Right? When you practice more and more, uh, sometimes you can actually jump from step 1 to step 5 straight away by ignoring these, because you can do the step 1, 2, 3, 4 on the one go, right? Rather than going through one by one. Okay? So once you practice it, it's very super easy. It's not that difficult. Right, now let's go through some basic stuff before we move into a narrative and see how to develop a ERD diagram from the scratch. Okay. First thing first. Now let's go through a little bit of stuff regarding how we're going to identify the entities. Right. Now we already know what you mean by the entity, right, or the object. So that is something that we like to represent in our database. Okay. Um, so so when you read the narrative, you need to actually recognize, is it a object, right? Is it an object? So if it is an object or an entity, it has to have many instances, right? You should be able to record many records, in other words. Yeah, it has to have more than one instance in that particular entity, right? So therefore, if you read the narrative and it says, okay, say for example, Swinburne University wants to develop a database for their enrollments, right? So if you say, okay, Swinburne University, it looks like an object, right? Can I create an entity for the Swinburne University, right? Actually, it is not an object, right? Because why? The reason is we should create a Swinburne University object or the entity, we should have only one instance, right? We have only one instance, one record. We don't have multiple Swinburne Universities in there, right? So that means the business probably is not an object at all, okay? Object at all. So how are you going to determine it? That we can apply this. So do we have many instances when you create that object? Okay. And then when you name the when you try to name the entity, you need to give a kind of a better name. So usually we use it in a singular noun. So don't use verbs to name entities, right? We use nouns. We usually use the uppercase characters to name the entities, but it's okay to use lowercase. I am not that fussy about that. But it's a good practice. It's a good habit to use the uppercase characters. Okay. And then the other important thing is when you're determining the entity names, it has to be a specific to the business. For instance, for example, if I try to develop a database for the university, I may have a students, right? We are not going to say the students as customers, right? To be honest, students are customers for the university, right? So in this case, in this education environment, we are not saying customers, right? We don't use that term very often, right? We use a student. We are not using client or customers, right? We use the term student, right? But in some other businesses, we use the term customer or client, right? So it depends on which the domain you are talking about or domain you are working with. Okay, so likewise, think about the business specific terms or kind of nouns when you're trying to capture the object, or how to name it, right? That is very important thing, because sometimes when you go to a different industries, like I remember one time when I worked in a kind of a chemical plant. Oh my gosh, it's too much of jargon words, right? I can't even remember these things, the chemical plant, because their industries are quite different normal industries, right? Now imagine if you go to a NASA or kind of scientific kind of areas and you're trying to develop some databases. So they may use a different kind of nouns, isn't it, to represent their objects. So then you need to adapt to it, right? So that is what we mean by this. And then the other important thing is, if it is an entity, it has to have a multiple properties or multiple attributes, right? That is another test that you can apply to see whether it is an entity or an attribute. Okay, so it has to have multiple properties. Okay, um, and then entities. Remember, the entities we categorize into two categories: strong entities and the weak entities. If it is a strong entity, it should have its own primary key or its own identifiers, like student number or actor number, etc., etc. If it is a weak entity, it can be partly identified by its own attributes or own primary key, and maybe sometimes we need to borrow it from the other related entities. Like, for example, classic example is the enrollment entity, right? And then we draw the weak entity using the double lines. Okay, single line for the strong entity, double line for the weak entities. Okay. So that is something that you need to think about when you're dealing with the entities, right? Now, with respect to attributes, now these are sometimes we are coming across sometimes problems and issues. So how are you going to identify? Now, when you identify the attributes, we need to use a single word, or sometimes we can use a small phrase as well. Um, um, so sometimes people actually in some industry, I know some one of my colleagues, they used to actually name it using the underscores or the capitalization to separate the different words if it's a phrase. So that's okay. That's okay to use. And then one of the important tests that you can actually test whether it is an attribute or an entity. Because sometimes when you work in these narratives, you may be confused, right? You may consider, actually, I confuse sometimes whether the particular noun is whether it is an attribute or is it an entity, right? How are you going to determine that, right? Now, you know the rules that we determine the entities, right? If it is an entity, it has to have many instances or many records that we can record inside that entity, right? If it is an attribute, right, you should not have more than one value. So you should have actually, sorry, it has to have more than one value, right? It has to have more than one value. It's not instances, but the values, right? The other important test that you can apply is if it should not have more than one property, right? It should not have more than one property, because if you have more than one property for a given noun, it is actually not a attribute. It might be an entity, right? So these are the simple tricks that you can actually apply and see whether it is an entity or an attribute, right? And one of the important things that you have to actually think about when you try to establish an attribute, it has a dependent existence, because an attribute usually dependent on its identifier. right? For example, student name is dependent on the student ID. Student address is dependent on student ID, right? Actor name is dependent on actor number, right? Subject title is dependent on subject code. So likewise, the attributes that we identify probably need to be dependent on its identifier. So that is what we mean by this point, right? Custom address is dependent on the value of the customer number, the identifier of customer number, etc. So likewise, these are small bits and pieces you need to actually remember, and sometimes these are the rules that you can apply and see whether it is it's actually an entity or it's an attribute, right? Okay, having said that, now it's time for us to practice to create an entity relationship diagram. Right, now imagine we have given this, someone in our development team may have gone to a business. It's a library, they have interviewed the people or librarian and other people, they have come across this small narrative, right? And they also have some photographs of some toys. Now this is a toy library, so they are trying to actually develop a library system or toy library system. The organization name is called the Glenferrie Toy Library, right? So they are trying to develop a system, and they develop this narrative, and you can see there are two toys here, right? Can you see the bar? Now these are not the actuals, right? This is not the actual baby. This is a toy baby. So you can see a kind of a barcode attached to that baby. And then there we have a rocking horse here, and it has a barcode as well. So you can, and then this is a sample of example of a patron's ID. Now remember the libraries and these sort of areas, we don't call them as customers, right? We have patrons, right? So this is a patron ID card, right? Like your student ID card, they have given a patron ID card. You can see there's a barcode, specific patron ID number is there, right? So these are the bits and pieces of information we have, and together with this narrative. Now let's read through this narrative. So Glenferrie Toy Library has many patrons. A patron has a name and a gender. Each new patron is assigned a sequential patron number. The library has number of toys. Every toy in the library has a unique toy number. Each toy has a description and a year of acquisition. Each time a toy is loaned to a particular patron, a date of the loan is recorded. When the toy is returned, the return date is recorded and the number of days borrowed is determined. Right? So this is a very small kind of a narrative, right? Right, now the first thing first, now what we need to do is, if we want to develop a database for this about this particular scenario for the given narrative, the first thing first, so what we need to do is, what I will do actually when I'm working in the industry, I'll actually underline the nouns and important things, right? So here I have underlined, right, that I believe is important objects that I wanted to capture, right? So I'll underline the patrons. It looks like an object that we need to represent in our database. And then they're talking about the names of the patrons, so I just underlined that or highlighted that, and gender and the patron number, right? So they're talking about patron numbers. And then the second point, they're talking about the live toys and the toy numbers, right? And each toy has a description and the year of acquisition, and then the toy can be loaned to the patrons. So date of the loan has to be captured, so that means it has to be recorded somewhere. So I just highlighted that. and when the toy is returned, the return date need to be recorded. So that means that is something piece of information I need to actually capture. So I just highlighted that. And then this is a bit doubtful for me, so I just highlighted that because it says number of days borrowed is determined. So I just highlighted that for a time being, right? Now, first thing first. So once I do that, what I do is there looks like there are more now, like Glenferrie Toy Library. That is another thing, right? Another now. So what I will do is I'll put that in a kind of a table like this. Now I need to identify whether I actually need this in my database. If I need it, what is that? Is it an entity? If it is an entity, whether it is a strong entity or a weak entity, or otherwise is it an attribute, or is it something I need to ignore, or it is something I can calculate, which I actually need not to actually represent in my database. Okay, because sometimes when you record some information, I can calculate something from based on the information. I need not to actually record that particular thing, right? For example, age, right? Age I can calculate based on my date of birth. If I record date of birth, I can calculate the age to date, right? By based on the age date of birth, right? So I don't need to actually record the age. Yeah. So likewise, we may have find these sort of information, right? So I just put into a kind of right. Now my question is, now I need your help, right, to identify each of these, right? So let's go one by one. So these are the things I have highlighted, important nouns. So let's go one by one and try to first clarify whether it is which category each of these belongs to. Right, now let's capture the first one. Glenferrie Toy Library. It looks like a noun, right? It looks like a noun, it looks like an object. Now, do we really need to capture that and represent it in our database? That is my question, right? So I need your answer. So everybody need to contribute. Right, Glenferrie Toy Library. What do you think, guys? What do you think? What do you think? Is it a strong entity, or is it a weak entity? Is it an attribute? Is it calculated something, or it's something that I need to ignore? So Vanessa, she says ignore. How about others? Liam, Duke, Hanjun, Cruz, Mugadesh, me, Shamin, Shenaz here. I got few ignores. Mori says I don't. Okay. Mori says it's weak. Kunja says ignore. Jun Hattori. What's your answer, Jun? Cruz. What's your answer? What do you think? Is it something that Shamin says ignore? Thank you, Shamin. How about the others? I need everyone's answer. So this is something that I really okay. June says ignore. Okay. Okay. Yeah. So the answer is actually ignore. Why we need to ignore this? By the way, why we need to ignore this? It looks like an idea, right? Now remember the rule, right? Now if I take this as an entity, right? If I take this as an entity, the rule that I can apply is, do we have more than one instance? If I create an entity called Glenferrie Toy Library, do we have more than one instance in my database for the Glenferrie Toy Library? The answer is no, right? We have only one instance. Glenferrie Toy Library means that's it, right? So we don't have more multiple records to represent that kind of entity or that kind of object in my database, right? So that means this is actually not an entity at all, right? So it is something that we should ignore. That's the business that we are focusing on. That is the business we are trying to build this database, right? Yeah, so therefore, Glenferrie Toy Library is something that we can ignore, right? We don't need to care about it. Okay, right. So Molly, did you get my point? Yeah. So it's not a entity. Okay, it's not an entity. It's something that the reason is we don't have more than one instance. Yeah. Yeah, then we don't have more than one instance because we are building that this system for the verificatory library, right? So we don't have more than one instance. Yeah, good. So the answer is ignore, right? Now they're talking about patrons. Yeah, so they're talking about patron. So what do you mean by the patron in this case? Is it what is it an entity? Is it an object, or is it an entity, or is it a kind of an attribute, or what is that? So your answers. I need your answers. Patrons. Patrons. What do you think? Shena says strong entity. Vanessa says strong entity. Others. This is very important, guys. That is why I'm going very slowly, because this is the basic stuff. If you don't get the basics, otherwise it's a bit tricky later. So let's go very slowly. Strong. Yeah. Good. That's a strong entity. Yes. Why it is a strong entity? My next question. Why you categorize this as a strong entity? So let's go back. Now, why we categorize this as a strong entity? Because when you read the second sentence, it says each patron has a name, a gender, and assign a sequential patron number. Now, if you think about this patron card, you can say each patron has a kind of a unique ID number. Yeah, unique ID number. So that means a patron is a strong entity. It's not a weak entity. Yeah, it's not a weak entity. The reason is this: it has its own unique identifier. Right. Yeah, so in the second one, the answer is strong entity. Yeah, right. How about this? Patron number, patron's first names, patron surnames, patron's gender. What are these? What are these? These are, yes, very good. These are the attributes, isn't it? These are the attributes of this object, patron. Yeah, they are the attribute. They are the one. They are the descriptors of patron. Yeah. So they are descriptors of the patron. Yeah. They are talking about toys. This toy. These toys. Okay. So what is this toy actually? Toys. Toys what? Toy is something that we need to represent, right? Definitely it's a object. Right? What kind of object is it? Is it a strong object or a weak object? That's my next question. Yeah, it's an entity. Yes, that's an entity or the object. Yeah. Is it a strong entity or a weak entity? It's a strong entity. Yeah. Why it is a strong entity? Because again, you can see each toy has its unique ID numbers. Yeah. Can you see the unique ID numbers? Yeah. So it's a strong entity. Right. So they're talking about toy numbers. What is a toy number? Toy number is an attribute. Basically, it's a primary key of the toy. Yeah, attribute. And the description means description of the toys. Yeah, description of the toy. So that means it's an attribute as well. Attribute of the toy. Okay. Year acquired. What do you mean by the year acquired? Year acquired means the year the toy has been acquired. Yeah. So that means it's actually description of the toy. It's another attribute. Yeah. So the toy number is an attribute. Description is an attribute. Yeah, acquired is an attribute. Okay. Date borrowed. Date returned. So what are those? Date borrowed. Is it a entity or it is something like an attribute? What does it sounds like? Date borrowed. Date returned looks like an attribute, isn't it? Not, it doesn't look like a kind of a entity. Yeah, right. So probably it might, is it belongs to a toy, or is it belongs to a patron, or it's not it's not at this point it's not that clear for us, right? Because date borrowed, date return means yes, toys borrowed by someone, right? And someone can return the toys, right? So looks like it's not belongs to truly to the toys. It's not belong truly to the patrons as well, right? So that means we can keep that for a moment, but it's definitely a kind of an attribute. It's not a not an entity, because we can have so many date borrowed values, right? So many people can borrow the same toy again and again. So we can have multiple values associated with date and also multiple values associated in the date returned as well. So yes, it's an attribute. Okay. Days borrowed. What is this one? Days borrowed. Days borrowed. It's a calculated thing. It's a calculator. Do we need to represent that in our database? Do we need to show it like an attribute or something? Yes or no? Calculator, yeah, that's right. Do we need to show it? No, right? We don't need to show it, right? Days, if you know the date borrowed and if you know the date returned, if you have these two values, you can calculate it. Days borrowed, right? So we don't need to actually store this information in our database. We can programmatically calculate it. Yeah, if you know the values of attributes, we can programmatically calculate it, right? So that means we don't need. We can actually, this is something we can ignore as well. It's a calculator, but also we can ignore, right? So likewise, this is that is what you need to do first, right? So just read it, and then you need to determine each of these nouns or phrases. What is those? Is strong, weak entity, or strong entity, or an attribute? Okay, good. Then what we can do is we can now, according to the step one, this is the step one now. We can identify the entities and the attributes. So I just listed all these nouns, and then I did try to identify the entities, strong entities first, right? So you can see the patron looks like a strong entity because it says it has a patron number. Toy looks like a strong entity because it says there is a toy number, right? So the patrons and the toys, these are the two strong entities that we can identify, and then the same time we can identify the attribute associated in each of these two entities, right? So patron number goes there, looks like the first name need to be attached to the patron, gender has to be attached to the patron, right? And then the toy, if you think about toy number has to go there, description of the toy has to go there, the year the toy has been acquired has to be there, etc., etc., right? And the surname has to go the patron as well. So the date written and date borrowed, probably it's not belongs to the toy, it's not belong to the patron as well. Okay, so let's see, the next step is the step 2 is now we attach the attributes to these strong entities, right? So I have attached, right? So I just missed one balloon there. And then what can I do then? I can identify what is the primary key of these entities, right? So just underline the primary keys, right? Okay, so this is step 2. And then yeah, so that the problem is the date borrowed attribute. Can I so sometimes we can actually test it. We can put these date borrowed into one of these entities and see whether it actually makes sense, right? So if I put the now if you think about the patron, if you think about the patron, you can actually put a kind of an test data to a patron and see, okay, for example, patron number 53, Sofia Vergara, she's a female. So that is what we mean patron. So that's one instance in the patron entity, right? One instance. So if I attach the date borrowed an attribute to this patron, so that means if you think about the Sofia Vergara, right? She is the patron number 53. So looks like if I put that one date borrowed, that means she can actually borrowed the particular whatever the toy in one day. That's the, because the patron number is the identifier, so you can't actually repeat. So that's, we are letting her borrow only once, right? If I put the date borrowed there, so that means date borrowed is actually not really attaching to the patron. It's not a good place to attach date borrowed, because the reason is, remember, the reason is we cannot repeat the patron number again and again and again here. So already have only one entry, because that's my primary key. So I have only one entry for the patron. So if I put the date borrowed, I can't let her borrow it again, another toy, right? So it's not make any sense, right? It's not make any sense. So the date borrowed not particularly um, attached to the patron entity actually. The same applies to the other side. If I attach the date borrowed to the toy entity, say for example, if you think about toy number T27, it might be the rocking horse or something. So if I put the date borrowed there, for example, 15 September, so that means I can actually let people to borrow this toy only once, right? The same problem applies, because story number is a primary key. I can't repeat it again and again. So if I borrow somebody, if I loan it, then it has to be only once, right? It's not make any sense, right? So that means the date borrowed probably, because we need to actually allow people to borrow the toy multiple times, right? So that means the date borrowed probably will not going to attach, will not actually suitable to attach in the toy entity as well. So it is not suitable to attach the patron entity. It's not suitable to attach the toy entity. So therefore, what we can do is we can leave date borrowed and the date return attributes for the time being part, right? So somewhere here, right? So we haven't attached to anything else. All right. So then the next step is we need to now identify the relationships, right? Now that is something that we need to think about. So identifying the relationship also, there are something that you need to know, right? So it is very important, because when you identify the relationship, you need to actually think about, do we really have the relationship between two entities? Is it worth to record that entity, that those relationships? Is it something that business is interested to record in their database, to capture in their database? And also it has to have a persistent. It's not to have a kind of a transient meaning, right? And then so you need to watch for the abstract nouns sometimes. So we need to be able to verbalize these relationships as well. So in this case, so it's actually, we need to actually establish the relationships between the entities, because we should allow patrons to borrow the toys, and toys can be borrowed by patrons, right? So obviously there has a kind of a relationship between the patron and the toy, right? So I just put the relationship here. I established that relationship line, and then I'll give a kind of a name like, okay, borrows, patrons, borrows a toy, right? Right? A patron borrows a toy. Okay. Yeah. So that is a step 3. And then the step 4 is what? Step 4 is we need to determine the cardinality relationship and cardinality constraints, right? Right. So how are we going to determine that? Now we have to think about, okay, now what's the business rules actually telling us this relationship? How many instances in one entity related with instances in the other entity? Is it a mandatory relationship, or is that the participation is mandatory, or is kind of an optional, right? That is what we need to determine, right? So if I go through if you read this kind of narrative, you will find out, right, they haven't actually mentioned anything about that, but it looks like we are allowing patrons to borrow whatever the toy they like, right? So they can borrow many toys as they wish, right? And then the toy can be borrowed by many patrons because there's no restrictions, right? There's no restriction. So that means we can actually obviously say there is a many-to-many relationship between the patron and the toy, right? So one patron can borrow many toys, and one toy can be borrowed by many patrons, right? So obviously many-to-many relationship, and the cardinality constraints also, there is no restriction. So perhaps or maybe, right, one patron may borrow zero or many toys, or one toy can be borrowed by zero or many patrons, right? So there is no restriction. So I just put cardinality relationship and the constraint as a non-mandatory. And then what I can do in this, as for the step 5, I can attach, remember these two attributes that we have put in unattached. So we can then attach that to our relationships, right? Uh, because it makes sense, because patron borrows toys in a specific date and return the toy on the specific date. So it has to belong somewhere here. It's not belongs to all these two entities, so it has to belong somewhere here in middle. Right, so now when I go through this diagram, you can see then we have a many-to-many relationship, right? So if you have many-to-many relationship, according to step 6, what we need to do is we need to expand it. We need to get rid of this many-to-many relationship. We need to create a weak entity in the middle, right? So I just create the weak entity in the middle. Now remember the rule: when you create the weak entity in the middle, these cardinality constraints need to be reversed towards the other side. So this one left side reversed towards the weak entity side, and the right hand side reversed towards the weak entity side, right? Okay, and that means now we can put the cardinality constraint more meaningful there, right? And then I can actually give a kind of a name to that as well. Now this is looks like a loan entity, right? So patrons loan some toys, right? Take the loans, or maybe borrows or something like that. Okay. So if you can't find a meaningful name, you can actually, what you can do is you can take these entity names, patron and toy, and then you can put the weak entity name as patron/toy. That's perfectly okay, right? And what we have to do is yeah, so what we need to do is now these two unattached attributes, now we can attach into the weak entity, right? Date borrowed, date returned has to come there. Okay. At the same time, you need to actually fine tune now the cardinality constraints and the cardinality relationship a little bit here, because you can see now here one patron may have many loans, right? So may have many loans, or zero or many loans, right? So we can have patrons without having loan. So that is why we have mandatory, or what you call this, optional participation, optional cardinality constraint in this case. But if you have one loan, right, it must attach to with one patron, right? So the other way, other direction, or right to left direction, it has to have the mandatory. Okay. Mandatory. So that's what we mean by here. So same rule applies to this side. One toy may have zero or many times loan by the patrons, or zero or many, but if you have one loan, it has to have attached to, it must have attached a toy. So therefore it's mandatory from left to right. Okay. Now remember, always we need to establish cardinality constraints and cardinality relationship in left to right and right to left, right? Yeah, so right, so there we have developed this. So we attach the two entity, sorry, two attributes to the loan. Now we can see whether it works. So now the first thing first. So what we need to do is, once we done that, so we need to now focus on the weak candidate and see what is actually the identifier or the primary key for the loan entity, right? Now actually though, you can see from these two it won't make any sense. We can't determine the primary key based on these two, right? So what we need to do is we need to think, okay, can I borrow something from the other direction, other two direction? Does it make sense? Yeah, so we need to actually think about, now if you think about the loan, a specific loan to a specific patron, because that loan has to have that patron, right? Because we are giving that loan to a specific patron, so they obviously the patron number is should be a part of their primary key, right? So the patron number we can borrow from the left hand side. So I just underline the relationship name here, right? Makes underline. And the same time, if you think about the loan, it has to actually have a kind of a specific toy attached to it, right? Otherwise it's not make any sense, right? So that means toy number has to be come from the other side as well to determine the primary key. So therefore I just underline the right hand side relationship as well. So the patron number comes here as a as a part of the primary key, and the toy number also comes there as a part of the primary key. So patron number plus the toy number, right? So if I take the patron number and the toy number, now if I write down the relational schema, you can see this is my relational schema. So this is the relational schema for my loan entity, right? So I just underline the patron number and the toy number. So same time I have two foreign keys, right? So these two will become foreign keys as well. Okay. So my next question is this enough? Is this patron number and toy number is a correct identifier, or is it we need anything else? Right? That's my next question, because we need to test it, right? So what we can do is, now we can put some test data and see whether it works. So what I have done here right now, I just put some test data, right? For example, for the patron, I created some fictitious two patrons. Patron number 53, Sofia Vergara, female, and patron number 71, Alex Dyson, the male. And then the two toys, toy number 27, rocking horse, and toy number 31, spinning top, right? I have two rows, and then what I have done, I put these test data into my loan entity. So you know the patron number and the toy number is my primary key, so so that is a composite primary key. Now what is the characteristic of composite primary key? So you can't repeat the same combination again and again, right? Okay, now you can see in this case, patron number 53, Sophia, uh, she borrowed the toy number 27 on 1st of June, right? And then again she is trying to borrow the toy number, same toy, the 19th July, right? So you can see a kind of a problem here, right? Because it looks like if I take patron number and the toy number as a primary key, now I have a problem because I can't repeat the same toy number and patron number combination again in this patron, the loan table, right? So looks like this model is not working perfectly, right? So that means now I need to actually think about something else, because it not make any sense if I take only patron number and the toy number as a primary key for my loan entity, right? So you can see this the second entry I can't enter because there is a duplicate primary key error, right? I have already 53 and 27. Right, so yeah, this is a description of that what I have said. So I need to now think about what else I need in the loan entity to make it as a unique primary key, right? To make sense in this business context. So I decided, okay, why not I underline the date borrowed entity, or so date borrowed attribute as a part of the primary key, right? So now if I underline these three, patron number, toy number, and the date borrowed, does it make any sense? Now let's see. So patron number 53, 27th, 1st of June. Now these are the three combination, right? Yep. So Sophia borrowing the spinning top, so rocking horse on 1st of June. And then you can see she borrows the same toy on 19th July. That's fine because now there's a no issue because the date is also part of the primary key. And she again borrows it in the 2nd of August, so that's perfectly okay, right? So looks like okay now, right? So the patron number, toy number they borrowed in combined will form a perfect primary key in this situation. But sometimes people may think, why don't I underline the second one, this one as well, date return, because that makes sense as well, right? Now remember, this is date written, this is not the due date, okay? Due date is something else, and this is the actual date written. Now the problem is, can I actually underline the date written, right? Doesn't make any sense? No, right? Because date written determined by the actual date the person has returned the toy, right? So when the toy borrow, when the toy has been, when someone borrowed the toy in a specific date, we actually don't know what date that she is going to return it, or he or she going to return it, right? So that means if you underline the date written, that's actually, this is not the due date now, remember this is the actual return date. So that means this is wrong, right? This is wrong. So date written, because obviously we need to keep we need to keep a kind of, we need to allow it null, because sometimes he or she may not never return the toy back, right? We should be able to keep null values there, okay? We should allow the null values, okay? So the date return we are not going to underline, okay? So the three columns that we take it as a primary key is patron number, toy number, and only the date borrowed, these three, okay? So that's about that case study. All right, now before I move into the second case study, I wanted to know how you goes. I need to know your feedback. Are you guys okay with that? Did it make sense? The first case study? Does it make sense? All good. Thank you, Liam. How about others? I want everybody in the same page. Remember? That's my idea. I want, at the end of the semester, my main objective is, I want to ask you a question. Are you enjoying this subject? I want everybody, oh yes, we like to specialize in database. That's my main objective, yeah. So how about Molly? Are you okay? Molly, Duke, are you okay as well? Duke, Jun Hattori? Okay, good. Sue, Sucheng Su, are you okay? Zia, Chanel, I think you should be okay, right? Yeah. Sia, Molly, Mugesh, Reagan. Reagan, are you okay with as well? Okay. All good at this moment? Okay. Okay. So have a look again. Okay, I'm just recording it so you can watch it again. Okay. Now let's go to my second case study, right? Actually, I should not remember this one because I'm getting very hungry when I see this piece this time of the day. Right, so PISA case study. Okay, so let's go through the PISA case study. Okay, right. Now let's think about this kind of business. Now think about the business. So small business, PISA kind of delivering kind of, they want to develop a small kind of a database, right? So so the name of this company is called PISA Online, right? Now, the Pizza Online is a small pizza delivery pizza kind of company. It allows customers to order pizzas via internet, right? Now, this is their first. When you go to their website, now this is a fictitious one. Okay, I just created. Um, so this is the first page, right? So when you go to internet, you go to their web page. This is their first page, very simple one. So what they do is they want people to actually, nowadays pandemic, right? So everyone is now order through the online, yeah. So this is their first page. Okay, so first, so they'll get this kind of a message: free delivery within 3 kilometers. Enter your customer details, order your pizza online, right? So what they need to do is, first they wanted the customers to customers to register their details, customer details, and then order the pizza online, right? Now what they need to do, okay, let's say if you're a customer, I will press the left hand side button, enter the customer details, right? I'll go to that screen. So this is their second screen. So they wanted to register our details, right? So the customer ID, now we can see the customer ID, it's auto-generated number, right? Auto-generated number. The rest we need to fill is a simple form. So surname, I just fill Smith, first name Fred, address, this is just a fictitious address, and this is a fictitious credit card number as well. Don't try this one, okay? This is not actual number. And then I press a proceed button, and then it goes to actually not this one. So it goes to this screen, okay? So I just ignore this one. So this is a third screen. Right, the second screen, third screen, this is the order form. So they have fixed menu. So you can see the order form, they have a fixed number of items in their menu. These are different types of pizzas, garlic bread, herb breads, colas, lemonade, etc., etc. And then they had a fixed price, right, for each of these. And you can see the item, they have item codes, right? Item codes, item names, item prices, and then what we need to do as a customer is to put the quantities, how many quantities we require in each of these items. We don't need, so the initial it will have a zeros. So if I want to change it, I just put 2, 1, 1, 4, 2, that's it, right? And then I press the proceed button. If I press the proceed button, it come to the fourth screen. This is the delivery instructions, right? It says, okay, what are the special delivery instructions? I say, okay, use the laneway entrance and knock the green door, right? So I just put, because it may be a small unit, so it might be a kind of a, not this, maybe yeah, unit inside the building. So I just put, okay, this don't knock the green door, and then I press OK. So when I press OK, it comes to the last confirmation page. This is the confirmation page. You can see it has all the details, customer ID, date, time of the order. So date, time was auto-populated, right? Date and time. Then name of the customer and the address, delivery instructions, all the items, price per item, the quantity, and the total price, right, including GST. Now guys, now these kind of web interfaces actually provide lots of informations how to develop the database, right? Now this is actually very good thing. If you go through any website, you can think about, right? So these sort of forms actually provide a lot of rich data, right, to think about, right, what kind of objects we need now. Now when you go through these web page, these sequence of pages, you will see, you need to have a kind of an idea, okay, what are the objects actually we need to capture. It's actually very easy to go through these pages rather than reading a narrative, right? Now when you go through these pages, now let's go through one by one. Let's start from here. Do we have any object to capture here? For example, Pizza Online, this is the company, right? Do we need a kind of an entity to represent the Pizza Online? Yes or no? Yeah? Or yes or no? Do we need any reference? No, right? No. Yeah, we don't need, right? This is why? Because we have only one instance, right? We have only one instance for this company, so we don't need any entity to represent pizza online. Okay, so there is no object actually in this screen. Okay, so let's go to the second screen. Here, the second screen. Do we have anything to capture here? Do we have any objects? Can you see any object? Any object or any entity? Any object? Yes, you can see this. They are talking about the customers. Yeah, they are talking about the customer. This is the customer page. So looks like there's a customer object, right? Or customer entity. Okay, customer entity is there, right? So what are these things? What are these things? Customer ID, surnames, first name, addresses, postcodes, credit numbers. They are what? They are attributes of the customer, right? They are the attributes of the customer. So my next question is the customer is a strong entity or a weak entity? So looks like a strong entity. Why it is a strong entity? Because each customer has its own unique ID, right? Own unique ID, right? So now we have captured our first entity, the customer entity, a strong entity, right? Which has a bunch of attributes, right? Bunch of attributes. And then I'll come to the next and second screen. This screen, do we have an entities here in this case? Right, it looks like this is an order form, right? We can have one order, right? Right, so looks like an order form, and then we have items, right? Now can you see the items? Each item in this particular company have its own ID numbers, item numbers, right? So looks like we have an entity called the item. So that item has different item numbers. So if you introduce a new item, we can actually record that in the item entity, right? Item entity, right? So looks like so what are the attributes of the item? Item code is there, item description is there, and item price is there, right? So what is these ones? What is this quantity actually? Is it belongs to the items? No, it belongs to the specific order, isn't it? It's belong to a specific order. If someone log into the system next minute, they may put a different quantity. So that actually quantities belongs to that particular order, right? So likewise, you need to think, right? So these quantities are actually belongs to a particular order, right? So there are two types of objects here, right? In this screen, there are two types of objects. One is the item objects. The one is the order object, right? Because order is very separate to the items. And now, and then we have this, right? Delivery instruction. Now, delivery instruction looks like what? Is it an entity? It looks like an entity or an attribute. This looks like what? Any idea? I need your answers. Is it an entity or an attribute? What do you think? Delivery instructions. This looks like an attribute. Yes, it looks like an attribute for an order, right? Because a specific order, they have different delivery instructions. Yeah, this looks like an attribute of that particular order. Yeah, right. And then when it comes to the confirmation order page, you can see. So let's go through. Then you will see a lot of information here, right? So we have a customer details. So we already captured, right? The customer entity, and then we have the order dates and the order time, right? So order date and order time is there, right? Now we need to capture that because we need to record that information, date and the time of the order. And then the delivery instruction we know how to capture, and then the items we know how to capture. Quantities we need to capture the quantities, yes, right? Because it belongs to a specific order, right? So quantities we need to capture. How about this total? Do we need to capture this total? This total, do we need to capture or store this total? Yes or no? Any idea? Total, do we need to capture it? Same rule applies. Remember last time, yeah, you don't need, right? Because it's a calculated thing, yeah. So if you know the price and the quantity, you can calculate the total programmatically, yeah. So we don't need to actually record this information. Right, now do we have an idea? Right, now we have kind of a basic idea, right? So we have now few objects are there, right? So we have a custom object, we know there are items, and then we know the order, right? So customers order the pizzas for the specific items, right? That is what it looks like, right? Customers can order specific items from this company, right? Right, so we can actually go straight away for this model, right? We can go straight away for this model rather than going through one by one. So we know the customers, right? So customers have custom IDs, names, and addresses, and also credit card numbers. I missed that, but you can put the credit card number as well. So the customer, they are talking about custom ID, so pretty much a strong entity, right? And then obviously the item is a strong entity as well. This company has different items, right? So item codes, description, and item prices are there, right? And then the order. Now order looks like what? Now in this case, order, I just put it as a weak entity. Why? Do we have the order number here? Right? There's no order number, right? So this order form, there's no order number, right? But they have given the order date and the time, right? So that now it looks like an order is not a strong entity, right? Right, but we have the date time, but it's not a strong entity. So that means the order is dependent on a specific custom, right? Specific custom. So the custom ID plus the date and time will make a perfect identifier for the order. Okay, perfect. So I just, now it looks like, now let's think about the relationship between the customers. So yes, customers can make many orders for a specific pizzas, right? So customer make many orders, but if you think about one order, one order must belongs to one customer, right? Must belongs to one customer. So I can actually straight away put a relation, what do you call this, cardinality relationship and the cardinality constraints, right? One customer can have many orders, one order must belongs to one customer, right? So the primary key for the order is custom ID plus date and the time, because I need to borrow it from the other side. So therefore I underline the relationship, right? So and then we have the delivery instruction attached to the order as well. But now when you think about order and the items, right? So how many items one order can have? Multiple items. So there is no restrictions, right? So, and one item can be ordered by how many times? There is no restriction as well. Like, so one item or garlic bread or one kind of supreme pizza can be ordered by many multiple times by many orders, right? So there is a many-to-many relationship between order and the item. Okay, so there is no restrictions. Okay, so many-to-many relationship. So that means if I have the many-to-many relationship, what I need to do is yeah, so in this here I am saying that here we don't have the customer, sorry, order ID. If we have the order, now think about this, if they have given an order ID, the order will become a strong entity, right? Because it has a specific order ID. But in this case, since they have not specified any order ID, we need to assume order ID consists of date, time plus custom ID. This is an assumption. Okay, so that is what I have mentioned in here. So don't invent an order number if the case is not specified anything else, right? If it is not specified, we need to live with it. We need to think about how we're going to determine the identifier with the existing attributes, right? So in this case, date and time and the custom ID. So in combination of these two things will make a perfect identifier. Okay. Right. So now remember the quantity, right? Now see the quantity. So these are the quantities. So each customer orders different quantities of each item, right? Now, so now we have a problem. Where are we going to attach the quantity? Yeah, it looks like it belongs to the order, right? But we can we put the quantity to the order? Probably not, because if I put the quantity to order, what will happen? I'll give you a kind of a, and I'll come to that later on. So the quantity actually obviously comes in the middle. Actually, it can't, and it looks like the same problem. Remember the last time, last case study, we can't attach that date, what do you call, borrowing date and date return to a specific customer or a specific toy. So same principle applies to the quantity. We can't apply it to the order or an item, because order can have different items with different quantities. So it doesn't make any sense if I put the quantity over there. Okay. And same applies to here. If I put the quantity into the item, that means this company can sell only the specific number of quantities, right? Because this actually quantity belongs to a specific customer, not the items that we are selling in this company, right? So it doesn't make any sense we attach it here. So what we can do is, we can put the quantity in this relationship, and then we know when we have the many-to-many relationship, we need to expand it and create a weak entity, right? So in this case, I created a weak entity and then attach the quantity to that weak entity. Now remember, as a rule, when you create the weak entity, the relationships has to be reversed and attached to the weak entity, right? And then I put the cardinality and participation constraints, or cardinality or cardinality relationship and constraint. The either direction, now you can see one order may have many order line items, right, with the different quantities. And one order line item must belong to one order, because you can't have a line item. So what do you mean by the line item, guys? Line item means this, right? Right. So we, in this particular order, we have 1, 2, 3, 4, 5 line items, right? That is what we mean by the order line. Okay. So each line item has a different quantities, right? So for example, P1 Mario Supreme line item has a quantity number 2, and the P3 Hawaiian pizza has a quantity number 1. So that is what we mean by the order line. Okay. And then each order line must belongs to a one item in our item list, right? That is what we mean by right to sorry, left to right, from the order line to item means. Okay. So I just put mandatory here, mandatory there. Okay. So you can see now what is the identifier for the order line now. So I need to determine the order line identifier. Obviously, it's the identifier for the order plus the identifier for the item, right? So what is the identifier for the order? Custom ID plus date and time. So it both comes to this side, custom ID and date and time, right? So I just underline here, and then I need to borrow the item code from the other side. So item code comes. So custom ID, date and time, item code will become an identifier for the order line entity, together with and we have an extra attribute called the quantity. So we have 1, 2, 3, 4 attributes in the order line item. Out of 4, 3 will become a primary key, right? Does it make sense? This is little this is confusing part, right? Because of this, right? Order line item. Okay. But it makes because just go through it again, and you will realize why we created, right? So now we can easily create our relational schema. So for the order, the relational schema like this green, you can see the custom ID and date and time underline. So we have a primary key, composite primary key, and then we have foreign key comes from the customer. Then the order line, this is the composite primary key, custom ID, date, time, plus the item code. And then we have two foreign keys. One is coming from the order, and the other one is coming from the item. Right. So then we can put actually some test data. and see how it goes. Now delivery instruction is a bit of tricky sometimes. So here in this case I attached the delivery instructions in the order rather than put that in the order line. And I can sometimes, if what will happen if I put the delivery instructions into the order line? There is a problem. What is the problem? Anyone, can anyone assume what will happen if I put the delivery instructions? It's not a big problem, but it can potentially lead to a huge problem if I put the delivery instructions into the order line. Who can guess correctly? Well, what is the problem if I put the delivery instruction here rather than here? It will repeat it, yes. So what is the problem in repeating? Now you can see one order can have many multiple order line items, yeah. So if I put that delivery instructions, it will continue multiple times, same thing many times. So what is the problem if we continue the same time? Remember, anomalies can happen, right? What will happen if the next minute the customer call, yeah, it's applied to one order, yeah, that's right, but we can put that there as well, Molly. Then what will happen if I put the order line delivery instruction here? What will happen? Because each single item, the delivery instruction will continue, right? So what will happen the next minute if the customer calls and say, okay, sorry, I made a big mistake. It's not the green door, it's a red door. You need to knock, right? So what will happen? We need to go through the whole every order line item and change the red door to green door to red door, right? Then what will happen if I forget to update something? Anomaly, update anomaly, right? So there are two types of delivery instructions in the same order. Which one is true? Because sometimes, yeah, that can happen. So that is why I put the delivery instruction in the order. So that means I have one delivery instruction for one order, right? One order. Of course, there can be multiple. Now we can order multiple products. We can order it for different delivery location. In that case, yes, then of course you need to put the delivery instruction here. But the pizza kind of thing, I don't think it's suitable to have these different delivery instructions. Right? So that is the reason why I put delivery instructions under the order, not only the order line. Okay. So these are the bits and pieces you need to think sometimes. Bit tricky things, isn't it? Little tricky things. So sometimes you need to actually think about these things when you design your databases. Okay. Yeah, so the order line is the weak entity. Yeah, so which one now? If I ask another question, which one actually gives you most valuable information for the owners of this pizza outlet? Which one is the most important? Is it the customer? I don't think so. Of course, customers are important, but for the money wise, which one is the most important one? Order line, right? Order line entity, right? Because that actually gives you how many quantities each item you have sold, right? So it will give you the how much of money you make, right? Isn't it? So you can see. Remember that last week I told you when entities become weak and weaker, it will actually give more rich information for businesses, right? So in this case, the order line, right? Order line. Probably customer is important, but money wise, order line is, I think, because it actually keep the history of orders keep the history of what we have ordered. Order line actually is one of the key entity, I believe, in this kind of context. Yeah, so this slide explain what I have explained here. If I put the delivery instructions to the order line entity, That's the problem, because it repeats several times. Okay, so it can lead to anomalies. Okay. What is this one? Yeah, so this is something I think. Yeah, so I think I already explained this, so let's go back. Right, so if I revisit the Glenferrie toy library scenario again, so I just trying to change it a little bit. I put some little more information to make it something similar to the pizza delivery system. Now so let's change the requirements. So let's allow, okay, let's think about like this. Let's allow one loan to refer to many different items. So earlier, remember the earlier model, we allow only one item for a one loan, right? Now, if I give opportunity to customers, okay, the patrons, okay, you can have multiple items loaned in a given one under the one loan. How are you going to modify, right? And also, I wanted to record which library person conduct the loan process. So, who has approved the loan, etc. Who is actually worked at the front counter at the time the loan has been processed. So that information has to be captured as well. So how can I modify my existing Glenferrie toy library model? That's my next question. So if I revisit our model, so if I put kind of, right, these are the piece of extra information. So this time in the loan entity, I need to put the staff name, right? Remember the staff. It actually looks like the delivery instructions that I have put in the order entity in my pizza delivery system, right? Same rule, right? So I just put the staff name under the loan. But now again, I have now many-to-many relationship between the loan and the toy. So I can borrow, I can allow patrons to borrow multiple toys in a given loan, right? So remember the earlier case, if I go back, earlier one, we allow only, so it's actually the right one is this, we allow only one toy for a given loan, right? So one loan can have only one toy, right? But now in this case, if we allow multiple toys, we can have many-to-many relationship between the loan and the toy. So that means if I have many-to-many relationship like we did in pizza delivery system, we can have another weak candidate. In this time, I call it as a line item or loan item or line item. Sometimes we can call it. Actually, in this case, it has to be a loan item rather than line item. So I just name it line item in here. So okay. So this is a weak entity, right? So line item is a weak entity because here it records which loan has which toys, right? What are the toys belongs to which loan? So one loan can have multiple toys. That is what we are recording here. Okay, so what is the identifier for the line item? In this case, I need to borrow the identifier for the loan. What is the identifier for the loan? It's the patron number because it's underlined, it comes this side, date, and the date time borrowed will take as well. So patron number, date time borrowed from the left hand side, and the toy number comes from the right hand side. So all three together will form a composite primary key for the line item entity. Okay, so that's a weak candidate. So again, if I ask a question, which one is the most important for so in this time we don't put the quantities, right? Because we don't allow, because remember last time we have here the delivery pizza system, where's the pizza system, we have a quantity, right? Because why we don't want quantity to place in load, because no one person will borrow the same two or three same type of toy, right? A number of quantities not make any sense. So so we don't put quantity there. Maybe we can put something else. Maybe we can put some maybe fees charge, or sometimes if somebody return the toy in a different dates. Right now, this time, now think about this time, we can actually modify. Now see that we are letting the people to borrow the multiple toys. So the return dates of the each toy can be different. So the toy return probably belongs here, right? Not there, right? Because it belongs to line item, because each toy can be written in different dates. Yeah. So what we can do, um, uh, we can yeah, so I can actually now where is that? Okay, yeah, so this is the date time return, right? So date time return not belongs to actually loan. Now I can put the date time return to the line item. Okay, date time borrowed has to be loan because the loan processed in the same date, but the return dates can be different for different toys. Shinal, you have a question, why can't the loan be a strong entity? um, uh, no, why can't be strong entity? Why it is strong? Why can't it be a strong entity? Because if you think about the loan, right? Date time. So particular date, the particular time. We need to know who is the patron is, right? Who is the patron is? Uh, so we take the patron number with that as well, because we don't want same patron borrow the two loans at the same time, right? Same time. So therefore we need to combine the patron number with the date and time, right? That is the reason it becomes a weak entity, right? So patron number plus date time is perfect identify in this case. um, So that is the reason, Shena, right? Does it make sense? Right? Because we don't allow the same patron borrowers two loans at the same time. Okay, so it doesn't make any sense. Okay, so that's the reason why we take it. If you have the loan identification number, then of course this will become a primary. This will become, sorry, the strong entity. Since they haven't provided any loan ID or something, so we need to live with the information we have. So we need to take the patron number plus date time borrowed as a primary key for the loan. No, every entity with the borrowed identifier will become a weak entity, not the foreign key, right? Remember, from strong entities can have foreign keys as well. Remember the movie that scenario we have done, right? The movie entity, yeah. So movie entity is a strong entity, but it still has foreign keys, right? Uh, so so yeah. So if an entity borrows the identifier, then it will become a weak entity, right? So in this case, yes, we borrowed the patron number. So line item borrows the patron number, date time borrowed, and the toy number. So this will become a weak entity as well, right? So that is how you need to actually think, right? If you borrow, because sometimes entities itself, the attributes itself will not going to give you any idea to form a primary key. So you need to borrow something from the other entity. So that means that entity will become a weak entity. Okay, right. Okay, so we can actually put test data and see how it goes. Now in this time, the loan works okay, and the date, sorry, line item uh, uh, is okay, because remember we can't underline the time return as well, because we don't know which date that we return, because at the initially it has to be null. When we return, we update that to the specific date time value. Okay, so that is the idea. Yeah, so again, the line item in this case is the key entity. in the library scenario, because it will give you an idea how much of late fees we can actually charge from specific items from the specific patron. So for the library context, this is most important from the revenue perspective. Right, so how to draw ERD diagrams. I think I have demonstrated. You can use diagrams.net programs. It's a freeware, so you can actually, once you log in there, you can create the diagram, or you can share your you can save it into your Google Drive or OneDrive, whatever, and then you have to use the left hand tab. I think I have shown this one to you. Yeah, entity relationship tab or entity relation tab. You will see all these notations, right? So what you have to do is just simply uh, drag each of these notation, and you can uh, create the diagram. So only problem is to create these lollipops kind of thing. So you can use these general notation tabs to use these lines, and then you go back to right hand side, and from the right hand side you can select the ending position of the line with that lollipop, and then it will become. Then you, what you have to do is you just copy and paste the same line again and again. So that, right? So you don't just, you want to do only once, then you can copy paste the same multiple times.